In the depths of an ancient forest, a story unfolds in whispers. A single leaf, touched by an insect's footsteps, begins to pulse with molecular messengers. Within seconds, an entire tree awakens to the presence of its tiny visitor. Within minutes, a symphony of chemical signals spreads through the forest canopy, as tree after tree prepares its defenses. This is not magic. This is nature's internet, a communication network billions of years in the making. Welcome to a world where every rustle of wind carries messages, where soil conducts conversations, and where life itself is an endless exchange of information. Today, we journey into nature's most sophisticated communication networks, where every organism is both messenger and message. MIT Center for Bits and Atoms. What we're discovering about nature's information systems is revolutionary. Every living thing, from the smallest bacterium to the largest whale, is constantly sending, receiving, and processing data. It's the original World Wide Web. Beneath our feet lies an invisible marvel, a living network of fungal threads that connects entire forests in a web of shared intelligence. Through this underground internet, trees share nutrients, send warnings, and even nurture their young. This is nature's social network, perfected over 400 million years. Harvard Systems Biology. The complexity and efficiency of these natural networks is staggering. A single teaspoon of soil contains more connections than all of humanity's computer networks combined. Yet it operates with perfect precision. Watch as a school of fish turns in perfect unison, thousands of individuals moving as one. No central command, no overhead control, just pure, decentralized information flow. Each fish responds to its neighbors, creating waves of data that ripple through the school faster than our fastest computers. Stanford Bioengineering. Nature's information processing isn't just fast, it's incredibly elegant. These systems achieve with a few simple rules what our most advanced algorithms struggle to replicate. It's humbling and inspiring. Consider the dance of fireflies, synchronizing their lights across vast meadows. Each insect adjusts its rhythm to its neighbors, creating spectacular waves of light that pulse with mathematical precision. This is nature's wireless network, choreographing beauty through pure information. MIT Quantum Biology. What's fascinating is how these systems operate at multiple scales simultaneously. From quantum-level signals within cells to ecosystem-wide communications, nature processes information seamlessly across orders of magnitude. In the warm waters of a coral reef, a different kind of conversation unfolds. Corals, those ancient architects of the sea, coordinate their reproduction through chemical signals timed to the phases of the moon. Once a year, on a single night, entire reefs release their genetic messages in a synchronized display that transforms the ocean into a living data cloud. Harvard Medical School. The precision of these natural timing systems is extraordinary. When we understand how nature coordinates such complex events, we gain insights that could revolutionize everything from medicine to global communications. Deep within every living cell, DNA orchestrates an intricate ballet of molecular messages. This is nature's original programming language, writing and rewriting the code of life in real time. 4 simple letters combine to create instructions for building and operating every living thing on Earth. Stanford Center for Conservation Biology. The elegance of DNA's information storage is unmatched. In a single gram, it can store more data than all the world's computers combined. And it's been doing this for billions of years. Witness the remarkable language of bees, where complex dances convey precise maps to distant flower fields. Each wiggle and turn translates into distance and direction, creating a living GPS system that operates with remarkable accuracy. MIT Synthetic Biology Center. The efficiency of bee communication is a masterpiece of data compression. In a few simple movements, they convey information that would take us paragraphs to describe. It's the ultimate optimization algorithm. As day turns to night, witness the subtle conversation between flowers and their pollinators. Colors shift, scents intensify, and ultraviolet patterns emerge. A hidden language of light and chemistry that guides night-flying moths to their nectar rewards. Harvard Department of Organismic and Evolutionary Biology. These multimodal communication systems show us how nature maximizes information transfer. Every channel, visual, chemical, electrical, is utilized with incredible efficiency. In the depths of the ocean, whales sing songs that travel for thousands of miles. These haunting melodies carry complex information about identity, location, and social bonds. It's nature's long-distance network, operating in the world's largest communication medium. Stanford Woods Institute. The sophistication of whale songs reminds us that nature's information systems aren't just efficient, they're also incredibly beautiful. There's a poetry to these networks that we're just beginning to appreciate. Even in the smallest scales of life, information flows with remarkable precision. Watch as immune cells patrol your bloodstream, reading molecular messages that distinguish friend from foe. This is your body's internal security network, processing billions of data points every second. MIT Biological Engineering. The immune system is perhaps nature's most sophisticated information processing network. It combines pattern recognition, memory, and rapid response in ways that our best artificial intelligence can only dream of matching. As the sun sets over our planet, pause to consider the vast web of communication that surrounds us. From the quantum dance of photosynthesis to the global migrations of birds, from the molecular messages in your cells to the pheromone trails of ants, we are immersed in nature's endless conversation. Harvard Center for the Environment. Understanding these natural information flows isn't just about scientific curiosity. It's about learning the fundamental principles that could help us build more sustainable, resilient systems of our own. The future of human communication may lie in understanding these ancient networks. As we face the challenges of our increasingly connected world, nature offers proven solutions that have stood the test of evolutionary time. Stanford Department of Communication. Nature's networks are sustainable, resilient, and incredibly efficient. By understanding their principles, we might find better ways to design our own communication systems. As our journey through nature's information symphony draws to a close, remember that you too are part of this vast network. Every breath, every heartbeat, every thought is part of nature's ongoing conversation. In understanding these networks, we don't just learn about nature, we learn about ourselves. Join us next time as we explore another fascinating dimension of nature's genius. Until then, listen carefully to the world around you. Nature's greatest messages are often whispered in the quietest moments. Remember, in the grand symphony of life, every creature plays its part in the endless flow of information. The question is not whether nature is speaking to us, it's whether we're ready to listen.